Good morning, ladies and gentlemen. Welcome to Math 20-1, Chapter 5, Section 2, Graphing Linear Inequalities. Now, before we get that far, I want to remind you of how to graph a quadratic inequality. So, x squared is greater than or equal to 6x minus 8. Remember, subtract 6x from both sides, add 8, so you get x squared minus 6x plus 8 is greater than or equal to 0, or this is positive. Now, if we were going to graph this, we would look for our critical points. What two numbers add together to be minus 6 and multiply together to be plus 8? Well, if you graph this, also you can factor it, you can graph it, use quadratic equation, you can complete the square, whatever floats your boat, or x minus 4, x minus 2, so x minus 4, x minus 2, sorry, plus 2 to both sides, plus 4 to both sides. We get our two critical points, 2 and 4. Now, as I explained in last lesson, you are supposed to test a point in each section, or each part. However, you know since this is plus x squared, this graph opens up. So where's this graph positive? 2 to 4. Now, that is 2 is less than or equal to x is less than or equal to 4 because, sorry, this should be solid because it includes the number. Now, sometimes they will write it like that, 2 comma 4 with square brackets to indicate we're talking about including the point 2 and the point 4. However, that looks very much like a coordinate, so I don't tend to use that in grade 11. I just want to warn you, sometimes I do dumb things like that. I have to do that in grade 12, Math 30-1. I try not to do it with you guys. So, rearranging, factoring, solving. You guys remember that? And graphing. That's today's lesson. So, if I asked you guys to solve x is greater than or equal to 2, here's 2 on our number line. Since this is greater than or equal to, the equal to part means we include the 2, and every number bigger than that. The greedy fish wants the numbers bigger than 2. Now, if I put that in a coordinate plane, here I have to do some counting. This is 2. Note, it's this way, but it's everything to the right of this line. That's what we're looking for. So this is y is greater than or equal to 2 on the coordinate plane. See how that goes? Now, a couple more examples. X is less than 1. Well, on the x-axis, and note, I don't normally label the axes because if you can't remember that, go to -2 or -3, please. There's 1. Now, this is less than, so we use a dashed line to indicate we don't include this number, but it's everything less than x equals 1. Now, for y is greater than or equal to 2, use the y-axis, everything greater than 2, like that. Okay, so far so good? Now, you can graph these on your graphing calculator. For example, clear, x is less than or equal to 1. Now, the trouble is you cannot do it here. You have to go over here. Now see that where the line is, you hit enter, you get, you can draw a thicker line. You can also shade above, and you can shade below. So that is, sorry, y is less than or equal to 1. Sorry. We just had y equal to greater than or equal to 2. So greater than is, sorry, should remember to do the correct equation. No, you should spot, sorry. Enter, my bad. Nope. Not that. Not that. Try this again. Thick line above. There we go. So that is y is greater than or equal to 2. Now the problem is I can never remember which way to put the shaded line, less than or greater than, on the graphing calculator, so I don't tend to do it. what I tend to do is choose points on the graph, and this is what I want you to be able to do. Now, next one, y is less than or equal to x plus 2. Now, if you remember back how to graph y equals x plus 2, that's your m, so your b value is 2. That means it crosses the y-axis at 2, and the slope is 1. 1x, so it goes over 1, up 1, over 1, up 1, back 1, down 1. Now, if you're having trouble with that, y equals x plus 2, and I want to get rid of that. No, go back to the original line. There we go, like that. Now, once you've got that line, you're going, okay, am I choosing a point above, or am I above the line or below the line? So what I do is I choose a point below. Now, I like 0, 0, because the math is really easy. Now, just to be on the safe side, in case we bung it, choose a point on the other side of the line. Now, it doesn't matter where. You notice I chose 0, 0 because the numbers are nice. Now, where else can I get zeros? Like right here. So choose a point on both sides of the line and check with the original equation. So for this one, this is 0 is less than or equal to 0 plus 2, or 0 is less than 2. So this side of the line works. Okay, now, as I said, poop happens, so let's just double check the other side. Minus 3 is less than or equal to 0 plus 2. Oh, sorry. 0 is equal to minus 3 plus 2. Is 0 bigger than minus, is 0 less than minus 1? No. So I did choose right to begin with. So that's what I expect you to do here. Now the next one, y is greater than x minus 1. Graph y equals x minus 1. My b value is minus 1, and my slope once again is 1. Now notice the original equation is greater than, not equal to, so it's a dashed line. And for the last time, spend a moment drawing a nice graph. Anybody just randomly put slashes down, I tend to fail. Now, let's choose a couple points. Once again, 0, 0 is my favorite. It's not on the line, so we can use it. And choose another one. Now, try those two. So, let me see. 0 is greater than 2 minus 1. 0 is greater than 1. Nope. So it's probably the top side, but let's double check. 0 is greater than 0 minus 1. 0 is greater than minus 1. Yes, it is the top side. Okay? And shade it in like that. That's what I need to see. So I'm going to pause the recording. You guys do the green one. We'll come back and compare results, okay? Okay, welcome back. Oh, sorry, not supposed to see that. Okay, let's try again. Now, the first thing you got to do is graph y equals 2x plus 3. So I went to my graph here, and my table of values. Well, there's my graph. And then I went to my table of values and got some points. When x is 0, y is minus 3. When x is 1, it's 1, and so on. So I chose my b value, and then I started going up 1, sorry, over 1 and up 2. Then I played dash line because it's a greater than, not equal to. Chose a couple points. 0, 0, and 2, and 0. And then since I had the purple marker in my hand, I did the to the right first, and it didn't work. 0 is not bigger than 1. So I double checked the other side, and yeah, 0 is greater than minus 3, so that one worked. Okay? Now, the next one is little x minus y is greater than 2. Now, there's several ways to do this. If you go back to graphing, you can do x and y intercepts. X-intercept, y is 0, x is 2. The y-intercept, when x is 0, then y is minus 2. But most of you guys are just going to rearrange this, so it's minus y greater than minus x plus 2. And then what do? You divide everything by -1. So y is less than x minus 2. Remember, the greedy fish changes sides when we multiply divide by -1 or any negative number. Now, it's -2 is there, slope of 1. And let's check a point above and a point below. So now go back to the original equation just in case we screwed it up. 3 minus 0 is greater than 2. 3 is greater than 2. So it should be this side. But humor me, check both sides because I said so. 0 minus 0 is greater than 2. 0 is greater than 2. No, doesn't work. All right? So one side does work. Check both just in case you make a math boo-boo, because poop happens. All right. I'm going to have you guys pause the recording, come back. We'll do the purple one, then we'll do the pause recording and do the blue one. All right? So rearrange them so it's y equals. Okay, gentlemen, welcome back. I got y is less than minus 2x minus 2. Now, going to Mr. Graphing Calculator, that's my line. I find it easier to use table of values to plot my points. But you should be able to go find your y-intercept, -2, then go over 1, down 2, or back 1 and up 2, back 1 and up 2. Since it's a less than, it's a dashed line. Choose points on either side. And I did the black one first because I have the black marker in my hand, and that works. -4 is less than -2. And then I double-checked the right side. Okay? Now, 2x plus 3y minus 12 is greater than or equal to 0. You can do that x-intercept and y-intercept, set x 0, then solve 3y minus 12. Or, actually, I'll show you. Remember, x-intercept, y equals 0, so it's 2x minus 12 is greater than or equal to 0. 2x greater than or equal to 12. X is greater than or equal to 6, so your x-intercept is 6. And then your y-intercept, x is 0, so 3y minus 12 is greater than or equal to 0. 3y is greater than or equal to 12. Y is greater than or equal to 4. So my x-intercept is, sorry, my y-intercept is 4. I've talked about that. Some of you guys like that, but I know you guys, you're not going to do that. You're going to grab Mr. Graphing Calculator and do it because you refuse to think. The standard. So, minus 2x plus 12 plus 12. 3y is greater than or equal to minus 2x plus 12. Divide everything by 3. Wait, why am I doing this? You guys finish this. Do the graph. We'll compare results. So you pause the recording, do this, come back and compare results. Let's go. Pause it. Pause. Okay, guys, when I did this, I got y equals minus 2/3 x plus 4. I got my blue line like that. The y-intercept is 4, and minus 2/3 means I go down 2. Here's my y-intercept of 4. I go down 2 and to the right 3, or back 3 and up 2. So I got my line. It's greater than or equal to. The equal to part means it's a solid line. So I check a point on either side. Since the math is getting a bit much, I wanted to have a 0. So I went 0, 4 for my value above. Plugging that in, I got minus 4 is greater than or equal to 0, which is not. So then I checked my favorite 0, 0, and I got minus 12. Hang on. I did screw that up. Hang on a sec. My apologies, ladies and gentlemen. I screwed up my graph at the beginning. My y-intercept is 4, not 3. Getting old. Anyway, down 2 over 3. I'm getting a line like that. Those of you going, Mr. Sutton, you screwed it up. Yeah, I did. Oops. Life happens. Anyway. welcome to my world. Anyway, now I was going to say I'd like to choose a point that has 0 in it to keep the math simple. Offhand, above or to the right doesn't have one, so I'm arbitrarily going to choose this 3 and 3. Now, let's see if I can screw this up again live on tape. All right, 2 times 3 plus 3 times 3 minus 12 is greater than or equal to 0. So that's 6 plus 9 minus 12. 9 is 15. That's 3 is greater than or equal to 0. So yes, it's everything above. All right, so I think I got it right this time, but that's why we double check our work. 2 times 0 plus 3 times 0 minus 12 is greater than or equal to 0. Minus 12 is greater than or equal to 0. Okay, now double checking. No, minus 12 is not greater than 0. Okay, now that was mildly embarrassing. Moving on. Everybody have your laugh? Now, what's one problem here is what's the equation? Now we're going to do a couple of these, and then it's going to be word questions. Anyway, so what's the equation here? Now notice this is a straight line. So you go back to y equals mx plus b. Now, your b value is your y-intercept. What is your y-intercept? Plus 2. Now, m is your slope. So what can we say about our slope here? We go down 2, and we go across 3. So m is rise over run. Notice I said we went down 2, so that's minus 2/3. So this is minus 2/3 y equals x, minus 2/3 x plus 2. Now, if you don't believe me, and after that last example, you really shouldn't, let's go y equals, clear, negative 2 divided by 3x plus 2. Graph, we get that. And we go to our table of values. 0, when x is 0, y is 2. When x is 3, y is 0. So yes, we're getting, our two intercepts are the same, so we have the same graph. Now the question is this a greater than or a less than? At this point, I'm not going to even try guessing. What I am going to do is choose a point on either side, choose a point on the side that works. Now, arbitrarily, I'm going to choose this point here because it has a 0 in it. This is 4, 0. Right? So every time I see x, I replace it with 4. Every time I see y, I replace it with 0. Now, minus 2/3 plus 2. So what is minus 2/3 of 4? Well, that's minus 2, that's 8/3 plus 2. Now, if you grab Mr. Graphing Calculator, negative 8 divided by 3 plus 2 equals minus 0.6666. Math, fraction, enter, negative 2/3. So 0, negative 2/3. Which is bigger, 0 or minus 2/3? Well, would you rather owe somebody no money or owe them 2/3 of a dollar? 2/3 of a pizza. 0 is bigger than. So the original equation is y is greater than negative 2/3 x plus 2. Okay? So far, so good? All right. Now, what's the equation here? Y equals mx plus b. What is my m value? And what is my b value? Well, what's easier to find? B, my y-intercept, is 3. Now, what is my m value? My slope, I'm going 1, 2, 3, 4, 5, 6 over, 3 up, rise over run, 3 over 6, which is 1/2. So this is 1/2 x. Now, I need to choose a point in the region that works. Now, It's a solid line, so it's a greater than or equal to or less than or equal to. Don't choose a point on the line, it'll just confuse you. So, what's a nice point? Any point works in the shaded area. As I said, I'm lazy and I tried to get small numbers, particularly if it has a 0 in it. 0, 4. So every time I see x, I replace it with 0. Every time I see y, I replace it with 4. So what's 1/2 of 0? 0. So we've got 4 and 3. Which is bigger? The 4. So it's greater than or equal to. Because it's a solid line, we need the equal sign in there. Y is greater than or equal to 1/2 x plus 3. All right? So far, so good? Good. Now, moving on. You're renting out your neighbor's 120 square meter yard for parking during the Slave Lake mud bog. Notice you're renting out your neighbor's yard, not yours. If a truck needs 9 square meters and a car needs 6 square meters, how many vehicles can you park? And can you park 10 trucks and 8 cars? Right. So, renting out your neighbor's property and collecting money. Such a plan, as long as they're not home. Anyway, so here, what have we been doing with? We've all been doing inequalities. So, so you're talking about how many trucks and cars can you park? Now, how many trucks can you park? I don't know. Well, what do you call the number you don't know? X. Now, how many cars can you park? Don't know. What do you call another number you don't know? Y. All right? Now, look carefully at this. We have, for every truck, every X, it needs 9 square meters. And for every car, it needs 6 square meters. And what is the yard? 120. Now, remember, 120 is the maximum yard you have, unless you want to start parking them in the house, which I've seen, which not worth it. It's less than or equal to 120. If you can fill it exactly 120, you're maximizing your money. Now, can we graph this? Yes. I'm going to look at this and I'm going to ask you to do what? Simplify. So, minus 9x, minus 9x, 6y is less than or equal to minus 9x plus 120. Now, if you're going to put that in your graphing calculator, what are you going to do? Yes, divide everything by 6. So y is less than or equal to minus 3/2 x plus 20. That you can graph. Now, I'm going to ask you to pause the recording. I want you to graph y equals minus 3/2 x plus 20. Now, graphing this is important. And you see in the upper right quadrant there, we can see the line. Now, here, I want you to think about something. What's the minimum number of trucks you can park? What's the minimum number for X? 0. You cannot park a negative truck. So when we graph this, we're going something like this. What I'm trying to say is, you start at 0. So you have windows, you have a minimum and a maximum value. So go to Windows, right off the bat, 0 is the minimum number of trucks you can park, and 0 is the minimum number of cars you can park. Now, important question is, what's the maximum? Well, we go to our table of values. If we start at 0, y is 20. Okay, see that? So, I'm going to go, maximum is 20 for y. Now, I'm still trying to figure out what my maximum x is. We'll keep going. We park 9 trucks, 10 trucks, 11, 13. Oh, here we go. Something around 13 or 14. 13 trucks, we can park half a car. Can you park half a car? No, you can't. So it's somewhere around 13 or 14 for x. So I'm going to go 14. And there we go. We've got our x and y intercepts. Okay? See how that goes? So what I'm trying to stress here is careful with your windows. You can't have a negative number here. So this tells you how many vehicles you can park. So it would be the area on the inside here, not the outside. Sorry. Now, if we look at our table of values, this tells us how many vehicles we can park. 10 trucks and 5 cars. 11 trucks, we can cram in 3 cars. 12 trucks, we can cram in 2 cars. 13 trucks, no cars. Now, that is one part. The other part is, can you park 10 trucks that is x is 10 and y is 8. So go to your table of values. When x is 10, your maximum value for y is 5. So no, you can park 10 trucks and 5 cars, but not 10 trucks and 8 cars. No, 10 and 8 is out here somewhere. Actually, yeah, maybe more like that. So it doesn't work. Okay? Now, one more question for you guys to try. You have 50 to buy chips and pop for a party. Walmart sells pop at $1 a bottle and chips at $2.50 a bag. How much of what can you buy? Now, I'm going to help you set up the equation, and then you guys are going to solve it. We'll come back and check your answers. So, how much pop can you buy? I don't know. What do you call the number you don't know? X. Actually, I'll make it easier. I'm going to cheat. I'm going to call chips X and pop Y. Because now, why am I doing that? Because I'm old and I'm evil, but that becomes 1y plus 2.5x is less than or equal to 50. Now, why am I doing that? So I get nicer numbers. But you're graphing, so it doesn't really matter. Anyway, graph it, set up your graph, draw your graph, show me the windows. Okay, come back and we'll check our work. Okay, gentlemen, welcome back. I'm hoping by now you've graphed this. You got this. Now, this. Now, my big problem, of course, is the windows. So I went to my table of values, and I scrolled down till y was 0. That gave me x is 20. And, of course, I went back to my x-intercept, which is 50. Go to my graph. When x is 0, y is 50. So that gives me my values here. This is pop. This is chips. Oh, really should label these axes here. This is trucks. Cars. Anyway, label the axis so I know what you're talking about. Come on, next page. Pop and chips. So, as long as you're inside this shaded region, you can get whatever you want. So, if x is 10, that is, 10 bags of chips. How many bottles of pop can I get? Well, go to my table of values. When x is 10, I can get 25 bags. When y is, when x is 10, this is pop, sorry. So 10 bags of chips and 25 bottles of pop, maximum. I can get less. I can buy 24 bottles of pop and save $1, as long as I'm inside here. So this is 10 and 25. Now, can I do 10 and 20? Yes. I'm less than 25 for y. I will be inside the graph. Can I do 10 and 30? No. I'm outside the graph. It doesn't work that way. I have too much, and if you don't believe me, plug it in. 10 bags of chips is $25. 30 bottles of pop is $30. 25 and 30 is $55. I've exceeded my budget. All right? So if you can find, if it's inside the graph or on the line, it works. If it's outside, it doesn't work. That's what I need you to be able to do. All right? So any questions, shoot me an email or see me in class. Otherwise, give the check your understanding questions a try. Good luck. Good luck.